hydrogen recycling gains ground in semiconductor fabs. Hydrogen has long been a low visibility but critical input in semiconductor fabrication, enabling high purity processes that demand consistency and control. Yet, despite its importance, most hydrogen used in these environments is still treated as disposable, vented after a single cycle. That approach is starting to look increasingly outdated. Rising input costs and tighter environmental expectations are forcing manufacturers to reevaluate long-standing assumptions around resource use. What was once considered an operational given is now being questioned as a potential inefficiency. A recent factory acceptance test, FAT, completed by Hayat Hydrogen in collaboration with Nippon Sanso, points to a possible shift. The system, designed to purify and recycle hydrogen within semiconductor facilities, demonstrated that reuse may be more commercially viable than previously assumed. The key factor is cost. Traditional hydrogen purification methods have been energy-intensive and expensive, limiting adoption. Hayat's electrochemical process is expected to bring costs down significantly, potentially to around 15 to 20% of conventional alternatives, making recycling a more realistic option for large-scale operations. Moving towards circular hydrogen use. Historically, hydrogen use in semiconductor manufacturing has followed a straightforward linear model: supply, consume, and discard. While simple to manage, that model is increasingly at odds with both cost control strategies and sustainability targets. The alternative being tested introduces a more circular approach. By capturing hydrogen after use and purifying it to required standards, the system enables reintegration into the production cycle. This reduces waste and can ease reliance on continuous external supply, particularly in periods of price volatility. At the technical level, the electrochemical purification process removes the need for mechanical components. Fewer moving parts can translate into lower maintenance requirements and reduced operational risk, an important factor in environments where uptime is tightly managed. The partnership behind the system also reflects how industrial technologies typically reach market. Hayat Hydrogen contributes the core purification technology, while Nippon Sanso brings experience in gas systems integration and access to established customer networks. That combination increases the likelihood of deployment beyond pilot stages. With semiconductor demand continuing to grow, driven by AI, advanced computing, and connected devices, incremental efficiency gains are becoming more valuable. Hydrogen recycling may not be a headline innovation, but it represents a practical lever for reducing both costs and emissions if implementation can scale effectively.